Okay, here is a video that presents the first 4 parts of Chapter 2, our chapter that's on specialization and exchange, or trade. So in this video, I'll be working you through the assumptions of the trade model, how to draw, shift, and rotate production possibility frontiers, or PPFs, what absolute and comparative advantage mean, and how that we represent them and calculate them. And then we'll use all of this and build upon it in class on Monday to calculate the gains from trade, both total and individual. So again, in this video, I'll walk you through 1 through 4. So first of all, what is our trade model? What assumptions do we make? Remember that one of the key features of economics is we use models with underlying assumptions to make predictions about human behavior. So in our trade model, we're going to assume there's 2 producers. These could be countries in an application to international trade. They could be individuals, as in 2 roommates, like the example on your problem set or your practice exam, I believe. Or it could be 2 workers in a factory. Think of stapling and folding in the widget factory. And in our model, we simplify to assume there's only 2 goods being produced. So you can already see how this is a massive oversimplification of the world economy, where there are way more than 2 producers and 2 goods being produced. But as we often see, humans are great at thinking and drawing in 2 dimensions, so we tend to simplify problems down at the beginning of making a model. Important in this model, each producer has their own technology. That could be shaped by their investment in technological change, by their resource endowment, right? What the geography of their country looks like. If we're talking about individuals, it could be based off of their skill set, their personality. And so within this model, each individual or country wants unlimited production. They want to produce as much as possible, but they're constrained by their available hours or workers, their resource and input endowment, how much land, labor, and capital does the country have? Are they land rich or are they labor intensive? All of that tends to lead them to specialize in certain products, but they essentially cannot produce as much as they would like because they're constrained by all of the things that go into production. So I'm going to do an example of international trade where we have 2 countries, the US and Japan, and they're making tuna and football. So 2 producers, the US and Japan. 2 goods being produced are football and tuna, and they each have their own technology. So the US uses all their resources. They can either make 4 football games, or footballs, or 2 tuna, right? These are clearly small numbers. We like to avoid zeros when we can in this class. And Japan, similarly, if they use all their resources to produce football, they can make 6 football games or 5 tuna, okay? So that would be the setup. I would have to tell you the 2 countries, the 2 goods, and how much they can make of each good when they're spending all of their energy making the good in question. Using that data, you should be able to do the second part of the model. So now that you know the assumptions, you should be able to draw production possibility frontiers. Okay, so we're going to do the US over here. Just a reminder, we're doing part 2, which is drawing PPFs, rotating them, and shifting them. The US over here and Japan over here. And I'll just copy down the information that was given to you in the problem, which is the US can do 4 football or 2 tuna, and Japan can do 6 football or 5 tuna. We're going to use that to draw their PPFs. What a PPF stands for a production possibility frontier. Production possibility frontier. It tells us what the United States can do in terms of football and tuna when they use all their resources. So I will usually tell you which axis I want to be which for these. But it's going to remind you quite a bit of the budget constraints that we saw way back in Chapter 7. So let's do both countries with tuna on the x-axis of their production possibility frontier. Then the y-axis will be in terms of the other good, football. There's no price or dollar amounts in our entire trade model. All we know about are the two goods and the trade-offs that the countries have for making each of the goods. So if the United States focuses all of its energy on tuna, they will get 2 tuna and no football. So this is a possible point for them. If they focus all their energy on football, they will get 4 football games and have nothing to eat. So that's another point for them. And then we're just going to connect everything in the middle. This will be the PPF for the United States. Simple enough. Very, similar to the budget constraint in that it's showing us possible combinations of the goods, but these are not possible combinations in consumption, given your income. These are possible combinations in production, given your resources. Japan, they can make 5 tuna or 6 football games. This is the Japanese PPF. Just like a budget constraint, there's going to be some points under here that are possible but inefficient because they're not using all of their resources, and some points out here that are impossible given the resources that they have. Okay, so drawing PPFs, relatively simple. How could they move around? Let's say that I tell you US workers go on steroids. That makes them better at producing football and better at fishing for tuna. So it would shift all of their production possibilities out if you think the steroids affect football production and tuna production equally. Be like a parallel shift. What if I said there was a plague in Japan? That would shift the Japanese PPF inward because there are going to be less workers to produce football. The total amount of football they would be able to produce goes down, as does the total amount of tuna. There's also another possibility, which is that the PPF rotates. So let's say instead of US workers doing steroids, instead climate change in the US makes tuna populations almost disappear. So there's just not very much tuna available to be fished for. This would be the impact of climate change destroying tuna, only in the US. It would rotate the PPF. It doesn't affect how much football they can produce, but it changes the maximum amount of tuna possible, so it's a rotation. Similarly, in Japan, if instead of a plague, maybe they research some anti-concussion technology, so they can now safely produce 7 football games a year instead of 6. This would be if they did research on concussions. This does not change the total amount of tuna they can produce, but it does increase the maximum amount of football. Okay, so that's drawing a PPF, relatively simple using the information you're given. Rotating a PPF because of something that affects one of the goods but not the production of the other, and shifting a PPF when an event impacts the total amount possible to be produced for each good. You would get a shift outward if it's possible to produce more, and a shift inward if less. Okay, so that is PPFs. Next, we're going to discuss absolute and comparative advantage. Absolute advantage, it turns out, is relatively simple, and we don't use it for very much. It's kind of like the accounting profit of this chapter. Absolute advantage simply means who can produce more of a good. Remember that in our example, the US can do 4 football or 2 tuna, and Japan can do 6 football or 5 tuna. That means that the absolute advantage in football goes to Japan, because 6 football is more than 4 football. When the Japanese spend all of their energy on football games, they can hold more than the United States. The absolute advantage in tuna also goes to Japan, because 5 tuna is more than 2 tuna. When Japan spends all their energy on fishing, they can harvest more tuna than the United States. But importantly, absolute advantage does not determine specialization. You might think that because Japan is better at making both goods than the United States, they can't possibly benefit from any trades. But it turns out that that would be oversimplifying things. Because when Japan focuses all their energy on producing these football games, they give up a lot of potential tuna. And there's going to be some trade-off where it's worth it for them to buy a good from the United States and focus their energy on the other good. And that will be determined by our other way of thinking about advantage, which is the economist way, because it involves opportunity cost. And that is comparative advantage. Comparative advantage tells us who can produce the good at the lowest opportunity cost. Right? Going back to chapter 1, we learned that economists love thinking about opportunity cost, what you give up to get something. Now in our model, we don't have very many moving parts, right? We basically just have tuna and football. The opportunity cost of tuna is football production that you forego. Foregone football production is the opportunity cost of tuna. So whenever we express the opportunity cost of tuna, it will always be in terms of football games that we can't put on. Similarly, the opportunity cost of football is foregone tuna production. Tuna that we don't have time to go and catch because we're busy playing football games. I hope that makes sense to you. Our opportunity costs will be expressed numerically, but they will always be for one good, just in terms of the other. We have two ways of calculating opportunity cost. The first way, I think of it as like an algebraic kind of manipulation or conversion. And the other way uses the slope of the PPF. So using our numbers for Japan and the US, I'm going to show you how you would use both methods, and it will be completely up to you whichever method you prefer to use. Okay, so here is the US on the left-hand side. They can make 4 football games or 2 tuna, and their PPF looks like this. We had tuna on the x-axis and football on the y, and the intercepts were 2 and 4. So the first way of doing this, the algebraic conversion way. In terms of resources, 4 football is equivalent to 2 tuna for the United States, because the identical amount of resources can either produce 4 football games or 2 tuna. And when we ask about the opportunity cost of football, what we're really saying is, what do I give up to get 1 football game? For 4 football games, I give up 2 tuna, right? If I want to move from here to there and get 4 football games, I have to give up all 2 of the possible tuna. But for 1 football game, if I want to have 1 football game on the left-hand side, I just divide both sides by 4. 1 football game is 2/4 of a tuna, or 1/2 of a tuna. That means the opportunity cost of football is half of a tuna fish. Each football game that I put on in the United States, I give up half of a tuna fish. Similarly for tuna, what we're really trying to do is to isolate what 1 tuna is worth. So if I want to do that, I simply divide both sides of the equation by 2. And that will give me 1 tuna and 4/2 football games, or simplifying that fraction down, 2 football games. That means that the opportunity cost of tuna is 2 football games. Each tuna fish that I go fishing for in the United States, I give up 2 potential football games I could have had. Now let's use the PPF instead. So the other method is when we use the slope. Here are 2 rules. The first rule is that the opportunity cost of the good on the x-axis, let's say that 5 times fast. The good on the x-axis in our model, tuna, will always be the slope of the PPF. Remember, rise over run. Well, in our PPF, you can see that the rise of that line is the y-intercept. For the run would be the x-intercept, 2, and that means the slope of this PPF is 2. You don't need to think of it in absolute value terms because we always know that opportunity costs are negative, meaning that we're always giving up 2 football to get 1 tuna. So this tells us the same information. 1 tuna fish, right, the x-axis good, we give up 2 football. The opportunity cost of tuna is 2 football games. Secondly, the opportunity cost of the good on the y-axis, in our case, football, is always 1 over the slope of the PPF, or 1 over 2. Tuna fish. Right, because this is the opportunity cost of football, so it'll always be in terms of tuna. So we just used 2 different methods to tell ourselves the same thing. One thing that you'll quickly notice when you get enough practice doing this is that the opportunity costs are always the inverse of each other, 1 over each other. And that will be consistent for every single example you can think of. Okay, so I will do the same thing now for Japan, just so you can see me do it one more time. Then you'll have plenty of time to do it in class. So remember, for Japan, they can either do 6 football games or 5 tuna. So that means in terms of resources, 6 football is equivalent to 5 tuna. 1 football is equivalent to 5/6 of a tuna. You can put that in decimals. It can be easier to compare. About 0.83 tuna. That's the opportunity cost of football. And if we wanted to isolate this down to what 1 tuna is worth in terms of football, we would divide both sides by 5. 6/5 of a football is equal to 1 tuna. That's 1.2 football games. So the opportunity cost of football is 0.83 tuna. The opportunity cost of tuna is 1.2 football games. And now in class, we'll talk about how we use those opportunity costs to decide who should specialize in which good.